Okay, we've shown all the equipment in the previous video. Now we're going to set up the oscilloscope. And this digital scope is really smart. It does all the jobs that you'd want a typical oscilloscope to do, and it does them really cleverly. There's an auto set button here which will pick the correct gain settings for the signals that it can receive at the moment. You can see we have channel 1, which is the output. Sorry, the input. Channel 1's the input, so it's the yellow signal on the screen. Channel 2 is the output, that's from the mass, it's the blue signal on the screen. And when I press the auto set button here, then automatically the correct gains will be set. What it doesn't do particularly well is pick a good time base, so you don't really get to see what's happening there. So by adjusting the time base down here, you can see I can get an actual waveform coming out that makes a bit more sense, and it's picked a suitable waveform for each of these signals. So I want to adjust the input signal so that I can see it reasonably well, and having adjusted that, I then want to also press channel 1 and adjust its position on the screen. And what I'm doing here, adjusting this, is moving this 0. So the 0 for the yellow signal is moving down the column here. Can you see that move down? So now I've got a full screen display. I adjust, press channel 2. There, that's channel 2. Adjust the volts division, and then adjust that up. And what I'm doing there is moving the 0 position for that AC signal up the screen. Okay, so now you can see the two signals are fairly well displayed over the screen there. I guess I could turn the time base down just a little bit. That's up, that's down, that's down. And then once I've got what appears to be a waveform and a half, or two waveforms, I can freeze the signal using the run stop. So I press that button, and there you see it's frozen the signal. So we can see just over a waveform and a half there. Peak to peak's one waveform, and then another half waveform in each case. Having set that, I can now measure, and in fact it's usually best, to be honest, to leave it running so that those values settle down, because you see what's happening is it's sampling them, and as it samples it's getting a more and more accurate measurement. If it's not getting enough data, then it can't measure very accurately, and sometimes when that happens, if it keeps jumping around, it won't settle on a value. What you have to do then is up the time division to get more waveforms. It needs more data, so by increasing the number of waveforms, you can see it starts to stabilize. Now it is still adjusting, but very much less than it was. So the small changes, but not nearly as many. So now, if I wait for it to settle down a bit, so that seems pretty well settled now. You can see that the peak to peak voltage for channel 1 at the top there is 324 millivolts. Channel 2 is 1.66 volts. I'm not interested in the average waveform. The frequency of each is 3.388, and that's to be expected for both channel 1 and 2 because they both have the same input signal. At the bottom is the time period, 295.2 milliseconds for channel 1, 295.6 milliseconds. So although they should be identical, you can see that they're not exactly identical, but you saw that from the frequency anyway. And of course the period is the inverse of the frequency. If you took that period in milliseconds, inverted it, you'd get the 3.388 Hz for channel 1 and the 3.383 Hz for channel 2.